Hello guys, welcome to Okonkwo Academy. In this lecture, I'm going to show you guys total probability rule and Bayes rule. And under this concept, I'm going to also solve some questions with you guys to better your understanding on this concept. Now, I'm going to use a Venn diagram to explain this as well. But if you are new to this channel, I recommend that you subscribe and put us on post notification and continue supporting us so that we can hit 2,000 subscribers this year. Let's move into this concept. So I'm going to use a Venn diagram, as I said. So suppose we have two events, right? A and B, and also B prime, right? B prime is the event where B will not occur, right? So um, I can represent the event A by two mutually exclusive events. Mutually exclusive event means that these events cannot occur together or at the same time. So this event, right? So for this portion can be represented by A intersection B, right? Because if this whole thing is A, right, this portion is the portion that falls in event B as well because this portion is B. All this portion is B, right? So this small portion, let me represent it by a black. So this portion of A, right, falls in B. So it is A intersection B, right? And this portion as well, this portion is A intersection B prime, right? So the union of it gives A. I hope you all understand to this point from what I've illustrated on the Venn diagram. So if this is true, and if we can see that on the Venn diagram, then the probability of obtaining A can also be represented by the probability of this whole expression. If that is true. So you can confirm this set notation by giving yourself two events, then you confirm whether that is true. So you can use events, let's say a set of 1 to 9, right? And A is the event of even numbers of this set, and B is the event of odd numbers of this set. Then you confirm this notation. You will see that it is true. Now, if the probability, right, of A is equal to this whole expression, then we can write the probability of A as the probability of A intersection B plus, we know that union is addition, right, plus the probability of A intersection B prime, right? From conditional probability rule, we saw that the probability that A will occur given B can be represented by the probability of A intersection B, that is A and B occurring, divided by the probability of B. If you remember, if you've not done conditional probability, please check my previous video, but I will add it in the description of this video as well for you to go and rewatch. So I can make this the subject, right? So making it the subject, I'm going to get A multiplying the probability of B, right? So same can be said for A intersection B prime. So I'll just write a similar thing for A intersection B prime. So replacing these two by this, right, I'm going to get the probability of A to be equal to probability of A given that B has already occurred multiplied by probability of B plus probability of A given that B prime has occurred multiplied by probability of B prime, right? So this is what we call the total probability rule. The total probability rule, right? Now moving on to the Bayes rule. The Bayes rule is actually built on conditional probability and the total probability rule. So we are just building on it. Now we know that the conditional probability of A, given that B has occurred, right, is equal to A intersection B, all divided by probability of B, right? You let me rewrite this. Let me do it the opposite way instead, so that I'll be dynamic small. So the probability of B, given that A has occurred, should be equal to B intersection A, all divided by what? Probability of what? A, right? Now, the Bayes rule is a combination of the conditional probability rule and the total probability rule. Now, for the Bayes rule, we are going to replace the probability that A has occurred by this, right? Yes. So, replacing that, I'm just going to replace that because we've already proven the total probability rule. So, sorry, let me draw a proper straight line. Forgive me, my straight line is not nice. So, plus probability that B will not occur, multiplying probability of A given that B will not occur, right? And also the numerator will be there. We are not done. We are not done with the Bayes rule. Now, we should know that intersection and union are commutative. Why do I say that? What do I mean by that? So, A intersection B is equal to B intersection A, and A union B is equal to B union A. We can confirm that by giving ourselves some examples. I like to really do examples so that we see that it's true. Let's say A is even numbers less than 8, so 2, 4, 6, and B is even numbers less than 10, so 2, 4, 6, 8, right? So if I'm asked to find A intersection B, that is elements that are common in A and also common in B. So my answer would be 2, 4, and 6, right? What if I'm asked to find B intersection A? It's still elements that are common in A and B as well. So that one too will be 2, 4, 6. So that means that this is equal to this. This is equal to this. So they are commutative, right? The same applies to union. So you can try union as well. You see that it is indeed commutative. So if that is so, then I can say that probability of B intersection A should be equal to probability of A intersection B, right? So probability of B intersection A should be the same as probability of A intersection B, right? So now the Bayes theorem in summary, right, would be equal to probability of B given that A has occurred is equal to probability of A intersection B, all divided by probability of B multiplying probability of A given that B has occurred plus probability of B prime given that probability of A given that B prime has occurred, right? So this is the Bayes theory. I hope we get it up to this point. Now let's solve the example. Let's solve the example. Now the example is a combination of everything. It's actually a combination of all the rules. It is a combination of the Bayes theory and the total probability theory. So we would understand it better. So let me delete all this and let's do the example. Okay, so oh Sorry, let me delete everything and let's do the example. Okay, so let's move on to the example. So the example is saying that in a certain assembly plant, three machines B1, B2, B3 makes 30%, 40%, and 25% respectively of the product. So machine B1 makes 30%, B2 makes 45%, and B3 makes what? 25%. So the probability of B1 would be 0.3, probability of B2 would be 0.45, probability of B3 would be 0.25, right? Then the second sentence goes like, it is known from the past experience that 2%, 3%, and 2% of the products made by each machine are defective, right? So now they've told you that this percentage of products are defective, right? They've told you that this percentage of products made by these machines are defective, right? So let's say let A represent defective items. Defective items. Now I've already read the question, that's why I'm solving it like that. But let's read the question first before we come and solve it. Let's read it. So in a certain assembly plant, three machines B1, B2, B3 makes 30%, 45%, 25% respectively of the product, right? That means that 30% of 30% of the product are made by B1, right? 45% B2, 25% B3, right? It is known from the past experience that 2%, 3%, and 2% of the products are made by each machine respectively are defective. So it means that the machines, right, B1 makes 2% defective things or products. B2 makes 3% defective product, and B3 makes 2% defective product, right? Now, suppose that a finished product is randomly selected. What is the probability that it is defective, right? So what is the main idea that we are focusing on? The main idea is defective items. So we have to represent defective items by a variable. So you read the question, the last statement, what is the probability that it is defective? So it means that the main focus is defective item. So we have to create an item for defective. So let A be defective items, right? What we are finding is the probability of defective items, this, right? So we are going to use the total probability law. Why am I saying that? Why am I saying that? Now let's read this very well, right? So they said it is known from the past that 2%, 3%, and 2% of the products made by each machines are defective. Now we know that the products that are made by this machine are defective. So probability of defective, right? Given that it is machine B1, right, is what? 0.02, right? I hope we sorry, this is a mistake. This is a mistake. Okay. So probability that, right? Probability that it is defective given that it is produced by B1 is 0.02. Probability that it is defective given that it is produced by B2 it is what? 0.03, right? Because they've told you that this is defective but it's produced by this, right? So you know that it is produced from by B2. Probability that it is defective, given that it is produced from B3, is what? 0.02, right? So from the total probability law, right? From the total probability law, we are asked to find the probability that it is defective, right? So for you to not really confuse yourself, right? Uh, for you to always remember the total probability law, you can use multiplication. Assume that A over B1 is standing alone, right? So if you multiply by B1, you get what? A. Use the same concept for this, right? So now, if I multiply probability of B1 times this, I'm going to get A. If I multiply probability of B2 times this, I'm going to get A. If I multiply probability of B3 by this, I'm going to get A. So if I add them, I get A, right? So the same formula is what I'm going to use here. So probability of B1 times probability of A given B1 plus probability of B2 times probability of A given B2 plus probability of B3 times probability of A given B3, right? So this is just a wrong idea of representing the concept, right? But I want you to really get it so that in case you even forget the total probability formula, you can remember this. That if you look at this portion, right, it is A. Assume that it is A divided by B1, right? So multiplying B1, it will cancel B1 so that you get A. So that in case you interchange it and make it probability of B1 giving A1, right? The question, because if you even read it, it is not this, right? This thing means that this thing means that the product that are defective are produced by machine B1. But this, they said that if you read this question well, it says that it is known from past experience that the products made by machine, this one, because they specified the machine first before they came to tell you that are defective, right? So it means that it is produced by a machine B1 that are defective. I don't know if you get it. Yes. So that's how you represent it, because they are saying that the products made by each machine, right, respectively, are defective. So it means that the machines are specified before they were talking about the fact that they were defective. So you should write it in this form. So the one that is specified first will come before the condition, right, that the defective is being produced. This is a way of getting these questions right. Okay. So moving on. Moving on. After writing this formula, we just input our values. So we know that B1, right, probability that is produced from B1 is 0.3 times the conditional probability 0.02 plus for B2 0.45 times the conditional probability 0.03 plus 0.02 times 0.25. So punching this on a calculator, we are going to get our final answer to be the probability of producing a defective product is 0.0245. Okay, so this has made us gotten the answer, right? So this is the probability of obtaining a defective item. So we use the probability, the total probability rule to get this, right? Now the next question is that with reference to this same example, if the product was chosen randomly and found to be defective, now they said the product is chosen randomly and found to be defective, what is the probability that it is made from machine B? So look at this, look at this. You see, for this, when we were writing it in this way, they said that of the product made by each machine respectively are defective, right? So with this, they specify the machine before coming to tell you that it was defective. So the defective would have to come first before the machine, because the machine was specified first. So that was known first. But read this question. With reference to example 2.41, if a product was chosen randomly and found to be defective, so now they are telling you that it's defective first. So the defective has to come before that condition symbol. What is the probability that it is made by machine B3? So B3 will come before the condition, right? So this is what we are asked to find. So writing what we are asked to find is really important, right? So let's move on to the question. So the question is asking us to find this, right? So finding this, I can write it in this form. So B3 intersection A, all divided by what? BA, right? So B3 intersection A, all divided by what? A. So I've written the expression for you. I will leave you to solve it and tell me the answer in the comment section, so that I will check. I want to know whether you really understand it. We've already found this. We've already found this. So what you only need to find is this. We did that in the Bayes theory. We proved that in the Bayes theory. So I want you guys to do it for me to see if you really understood what we did. Or you let me just do it with you guys. Okay. So now we already know the probability that A would occur, or the probability of being defective, right? Now what we have left to find is B3 intersection A, right? And this is also A intersection B3, right? So this can be represented by the conditional probability law, right? So for the conditional probability law, I can say A B3, which I have, right, is equal to A intersection B3 all divided by probability of B3, right? So probability of A intersection B3 would be equal to probability of A B3 times probability of B3. Now this was given in the question, and also this is already known. So we can get them here, right? So it is 0.02 and 0.25, right? So 0.02 times 0.25, which is equal to 0.02 times 0.25, is going to give us 0.005, right, for probability of A intersection B3, right? Probability that it is defective and produced from machine B3, right? So we getting this, we can put it in this equation, right? In this equation, because we already know this. We know probability that it is defective. Our answer as 0. As 0.0245. 0.0245. So probability of it being produced from B3, given that it is defective, right, will be equal to 0.005 divided by 0.02, what was it, 0.0245, right? So we get our final answer to be 0.005 divided by 0.0245. So our final answer is equal to 0.204. So I've solved it for you guys. Thank you for watching this video to the end. Do all to like, comment, and subscribe, and share it to all your friends that are having problems in statistics and probability. Make sure to promote us so that we get to our target this year. Thank you.